To start the OpenBUGS application, we click the icon, which here is located in the lower bar. Then the application opens and shows the window that appears here. To run an OpenBUGS application, we need several files: the commands, the data, and the initials files. It is convenient to prepare first these files and store them with an extension txt in order to be more efficient and have the opportunity to make corrections and changes easily. To access these files and have them ready to be used, we must open them from the OpenBUGS software. To this end, we use the Open option of the menu File and look for the files as we do now. In our case, these files are stored in the desktop, in a folder named Regress. Since the folder contains files of different types, we need to indicate the system to show all file types, and we do this by selecting All Files. Open this folder, we find the file commands.txt, in which we have the model commands. For a better view, we change the font size, the bold option, and clear font type as Arial. Next, we repeat this operation with the data file that contains the data of the problem, and we also change the font. In addition, we locate the corresponding windows in such a way that we have easy access to activate them when necessary. Next, we proceed in the same form for the three initial files. It is convenient to repeat the random simulations starting from different or the same values in order to test the quality of the simulations. Once we have all these windows ready, we can start to use OpenBUGS to perform the simulations. First, we activate the commands window by clicking in its upper part. We note that to use the information contained in each window, it needs to be activated first. Do not forget to do this, because otherwise we will get an error. With the command window activated, we go to the Model menu and select the Specification option. Immediately, the Specification tool appears, and we click the Check Model button for the software to check the validity of the model commands. If the model is correct, you get in the lower left part of the window the model is syntactically correct message, indicating that we can continue. Otherwise, an error message is obtained explaining the cause of error. If this occurs, we need to correct the commands file and start again. Next, we activate the data file and click the Load Data button. Then the correctness of data is checked, and if everything is right, we get the message Data Loaded at the left lower corner of the window. In case of error, we must make the corresponding corrections, taking into account the error message, and start again from the model check. Next, we need to indicate the number of initial files to be used by tapping this number in the num of change field, as we do now. Do not forget to do this before compiling the program. The next step is to compile the program by clicking the Compile button. Then the program checks that the compilation is correct and provides the message Model Compile Otherwise, an error message appears indicating the cause of error. If this occurs, we need to make the corresponding corrections and start again with the model check and all other steps. Next, we load the initial files one by one using the Load Inits button, as many times as the number of initial files we have. Note that the chain number indicated in the field for chain is incremented automatically until the number of files is reached. Do not forget to activate the corresponding initial files before clicking the Load Inits button. After each chain is loaded, we get a message indicating an error or some indication of some pending initial files. At the end, we get the message model is initialized, for you to know that the process has terminated successfully. Before initiating the simulation, we must go to the Inference menu and select the Samples option. Then the Sample Monitor tool appears as shown, and we need to provide the parameters to be monitorized. To this end, we write the parameter names one by one in the Node field and immediately click the Set button for the system to accept the corresponding node as one node to be monitorized. In this example, we have 3 nodes to be monitorized, A, B, and Sigma. To initiate the simulations, we need first to define some burn-in simulation in order to stabilize the simulation process before producing the sample to be used. To this end, we go to the Model menu and select the Update option. Then the Update tool appears, as you can see, and we can provide the number of simulations used for the burn-in step. In this example, we provide 1000 simulation in the Updates field, and click the Update button for the program to start simulating. This is a very fast process, as you can see, during which the number of samples being simulated are indicated in the iterator field until the 1000 of them is reached. Next, we indicate the sample size of the final sample. We provide 10,000 simulations in the Updates field and click the Update button for the program to start simulating. This is a fast process, as you can see, during which the number of samples being simulated are indicated in the iterator field until the 1000 number is reached. This is the sum of the burn-in and the effective sample sizes. Next, we return to the Sample Monitor tool using the Inference menu and selecting the Samples option. Now we can select any of the monitorized parameters and get information about the simulated samples. For example, we can select the A parameter and click the Stats button to get the main statistics of the simulated values for the parameter A. We can do the same with the B parameter, or with the sigma parameter, as you can see. However, it is better to use the asterisk option. If instead of the parameter names we type an asterisk in the node field, this means selecting all monitorized parameters at once, and then we get their properties at once, as you can see. Similarly, clicking the Density button, we get the plots of the marginal densities of each node. Using the History button, we get a plot of the sequence of simulated values of the different nodes. The Trace button proceeds similarly. Finally, the Coda button permits obtaining the simulated node values, one file per node, but the values are stored and they correspond to the sample values in order, so that we can later build the multivariate sample without any problem. We can also use the quantiles button or the density button to get the quantiles or the densities of the selected nodes. However, do not forget to indicate the monitorized nodes you are interested in before running the simulation. I hope that this short explanation of how to use OpenBUGS in a practical case helps you to run your own examples.